Promoting Innovation in Climate Adaptation is the webinar we're starting today. It's part of the Kickstarting the Sustainable Recovery Series, an online program that brings you a series of virtual discussions, stories, and new research focused on how sustainable finance can be part of the COVID-19 coronavirus recovery and help countries build back better and stronger. Check out the program, mark your calendars for your favorite events, and make sure to join the conversation on social media using the hashtag #SustainableRecovery. We would like to know from you before we get started, and so if you go to slido.com and use the hashtag adapt2020 or scan the code on the screen right now with your phone, we would like to know where you're joining us from. We see lots of people from the United States, France, Ukraine, Germany. Thank you for participating. Today, for our session today, we'll have Julie Dana, Head of the Global Facility for Disaster Reduction and Recovery, GFDRR, from the World Bank, and Matthew Glachant from the Minas Paris Tech, PSL University, who's going to present the report. Now I give the floor to Julie to give some opening remarks.
Thank you very much, and hello everyone. Thank you for joining. Welcome to the World Bank Climate Group Sustainable Recovery Series in partnership with Innovate for Climate. My name is Julie Dana, the head of the Global Facility for Disaster Reduction and Recovery, which is a multi-donor trust fund that helps middle and low-income countries build resilience to natural hazards and other disasters. Very happy to be here today to host this discussion with Matthew and Simon on the current state of play of innovation in climate adaptation technology. It's certainly a really interesting topic for everyone to think about how we get solutions into the hands of those who need it most. We all know that innovation is critical for continued progress and sustainability, but innovation is really hard. And then the transfer of technology to developing countries is even harder. So even though we've seen tremendous progress in for example, in the disaster risk management agenda over the past 10 years, innovation is still kind of stable and flat. As development professionals, then one thing we're constantly asking ourselves is, how much can governments really do about this? Without stealing the thunder from Matthew and Simon's work, I wanted to note three things that I found very interesting about this effort. First of all, the research, and I'm sure they'll explain in more detail, was done using patent data, which was only possible thanks to recent development of the new EU topology for patents on climate adaptation. So previously there had been a classification on patents for climate mitigation, and in 2018 the EU expanded that to create a topology of patents for adaptation. This was released in 2018, and as far as we know, this is the first research on that database. Second really important point that I hope we'll get into in the discussion today is that there's a very big difference in the trends for transfer of innovation related to climate mitigation and climate adaptation. We'll talk about this a bit more, but the climate change mitigation, innovation, and transfer of technology is moving much, much faster than it is for solutions for adaptation. Finally, as we look at the research in the current context of the global pandemic, I think the implications become even more serious. Historically, transfer of technology is done through the establishment of global value chains. I guess a big risk in the current environment is that that technology transfer really slows down or becomes more complicated if we see contraction in global industry and companies moving manufacturing back to home countries. So looking forward to the discussion. Today we'll hear from the two main authors of the study, Matthew Glachant and Simon Touboul from Minas Paris Tech, PSL University, who will present their report, Innovation and Global Diffusion of Technologies for Climate Change Adaptation, a Patent Analysis. We're also joined by Christina Chan, Director for the Climate Resilience Practice at the global research organization World Resources Institute, and Miria Pegato, who's the practice manager and the lead of the Climate Action Group in the World Bank's Macroeconomics and Fiscal Management Global Practice. So they'll comment on the research after the presentation. And after that, we'll open the floor to questions. Matthew, over to you.
Hi, everyone. So I will present this report. So this is the front page of the report, which is available on the World Bank website and the GFDRR website. So this is a joint work with Antoine de Chevepret, who is a senior economist at the OECD, Sam Frankhauser, who is the head of the Grantham Research Institute at the London School of Economics. Jana Stover is at Kiel University, and Simon and myself we are at Mainz Paris State. So I don't need to spend too much time on motivation, but I just want to insist on 3 points. The first thing is that we should keep in mind that technology is probably the main means that has been used by human beings to settle in almost all ecosystems of the planet, and so to become the only global species. And we will continue, and this means technology will continue to perform that function in the future. So in this global warming world, this is the first point. The second point is that we have a reasonably good knowledge on the geography of the climate risks. So which countries are exposed to which kinds of hazards. And in contrast, and this is why this report I think is useful, is that we have very little knowledge about where technology that can be used to reduce these damages, to mitigate these risks are produced, and where they are used, in which country they are used. So it leads to the main question, which is addressed in this report. So does innovation today reach those, so the countries who need it most? And to achieve this goal, we do 4 things. First, we look at the pace of innovation in climate change adaptation in the last 20 years. And then we look at the countries that innovate and where do they diffuse their new technologies over the world. We pay a particular attention to the comparison of what we find with other technology fields, and in particular mitigation. And last, and probably most importantly, we relate all these innovation patterns and trends to the level of climate risks in the different countries, to the country adaptation mix. So yeah, it's true. So what we do is to rely on patents to measure these innovations. In general, so using patents is the usual approach in other domains. And the idea basically is that as patents give to the inventor the right to use or sell invention, the exclusive right, it indicates clearly the availability of economically relevant ideas that are available. And in order to understand how we use this data, it's useful to describe briefly how the patent system works, and in particular what is the patenting process. So the first step is that you find an idea that can be exploited commercially. And the first thing that you will do is to file a first patent if you want to use this tool to protect your innovation. And in most of the cases, what you do is to file this patent in your home country, which would be the inventor country. And then you have 18 months to decide in which other foreign countries you will protect this invention. And so after 18 months, you have decided to file in a certain number of countries where you plan to exploit this invention. So what we observe in the data, we observe all these patents. So we observe where they are filed, in which country, and the links between these patents, and in particular the link between the first patent and the other patents protecting the same invention, what is called, so the set of these patents is called the patent family. And so you can just count the number of so-called patent family to measure the level of innovation in general. And you can also use these red arrows here. So the link between the first patent and subsequent patents in other countries protecting the same innovation to have an indicator of the transfer from the inventor country to different recipient countries. Of course, here we do not measure really the innovation or the transfer, but the plans that inventors have in mind when they file these patents in terms of exploitation and dissemination and diffusion. And I will come back on this. So, as I said, it is quite usual, and so the drawbacks and the advantages of this approach are quite well known. The main advantage, and why is it so successful in many studies, is it's because you have a very detailed classification systems that helps you to identify the technologies at a very disaggregated level. And so in particular, you can identify now the inventions that deals with climate change adaptation. You have information for each patent on who is the inventor, his country or our country, and the country where he has decided to file the patent. But you have also drawbacks. The main one probably is the fact that you only cover technological, high-tech solutions, technological solutions that are the technological. You do not cover with this indicator softer forms of innovations, organizational informations. You also have difficulties to identify low-tech solutions. The second problem is that patenting is not the only instrument to protect innovation, and in particular terms, they rely also in industrial secrecy. And a third weakness, which is very relevant for this study, is the fact that you file a patent to protect against imitation. And so if you plan to exploit your technology in a country where the imitation risk is very low, you will not patent. And it is, for instance, the case of many low-income countries which have very low technological capabilities. So it's clearly an important limitation. And finally, this data that tell us that they indicate that inventors have plans for the future, for their inventions, but of course, they do not indicate whether these plans will be implemented in the field. So what we use for the study is a very well-known global database, which is called PatStat, which contains 100 million patents, cover almost all patent offices of the world. And what makes possible this study and what makes it novel is the fact that 2 years ago, the European patent offices has released classifications that allows us to identify among these 100 million patents those that are related to climate change adaptation. So this is the table which describes this so-called YO2A classification. And you can see that this classification is quite detailed. So we cover 6 categories: coastal and river protection, water management, infrastructure, agriculture, health, and other adaptation solutions. So we cover a wide range of solutions, such as passive air cooling or IT systems to forecast extreme events or heat resistant crops. So all these type of technologies are covered by this classification, and so by the study. So we use, so what we have done is to extract data from PatStats using this classification. So the period covered by the study is the last 20 years. We stopped at 2015 for data availability reasons. We have in our data 140,000 patents related to adaptation in these 6 fields that I've just listed, which represents about 0.5% of all the inventions in the database. So let's now look at a few graphs and tables. The first thing that we see here is the pace of innovation measured in terms of number of patented inventions. And it seems quite positive because you see a steadily increase in the last 20 years. But in fact, it is partly misleading this, because this type of upward trend is observed for almost all technologies, and partially reflects an increase in the patent propensity, the propensity to rely on patent to protect your innovation. So what is more interesting is to compare this growth rate with other fields, and this is what is indicated in this table. And so yes, we have this 6.6% annual growth rate for climate change adaptation, but which is just slightly higher than the average for all technologies in all fields, 5.6%, and which is much, much lower, almost half that of the rate observed for climate change mitigation. So basically, we do not see at the global level any redirection of the innovation efforts towards adaptations compared to other technology fields, in contrast with what happens for climate change adaptation. Second stylized fact, this innovation is highly concentrated in a handful of countries that are located in the global north and China. So here we have the top 5 inventors, and you can see that these countries, they account for almost 2/3 of the global innovation observed between 2010 and 2015. And so, as it is concentrated in a few countries, and as we can assume that these technologies are useful in a much more higher number of countries, the question of whether these technologies, these inventions cross borders is very important, and this is what is indicated on this second graph, which shows the share of in percentage, and so this is the vertical axis, which is the percentage of patents which are extended abroad. So, which is an indicator of the intensity of the transfer, the share of technology which is transferred. And here we compare adaptation, all technologies, and mitigation. And you can see that, for instance, if you compare to climate change mitigation, the transfer rate is much, much lower, twice lower, and also significantly lower than the average rate for all technologies. What also is important, not in this graph, but we can see in the data that once a technology has crossed one border, so once it has been extended internationally, the number of countries which is covered by a single patent is similar to the average, and similar to the number of countries in which climate change mitigation invention is covered. So here, it's important because from a policy point of view, it suggests that the reason for this low transfer rate is not that these technologies, adaptation technologies, are less applicable to specific national contexts. So I will come back on this. A lot of variation across technology fields. You can see almost, so this is the same indicator, the share of patented technology transferred from 10% to almost nearly 30% for indirect adaptation. What is important is also the geography of this transfer. So here, this table is what we call an origin-destination matrix. It describes where do the technologies come from and where do they go. And so, for instance, if we consider the upper right cell here, we see 66%. Basically, it means here that 66% of the inventions that are transferred internationally are transferred between high-income countries. 27% is the share of the technologies which are transferred from one high-income country to a middle-income country. And so you see plenty of zeros on the last column and the last row, which shows you that, in fact, basically the low-income countries, they are nearly not connected to this flows of patented technology. This is not specific to this technology field, by the way. And the last graph that I want to show you is this. So what we have done here is to relate our data, our patent data, with climate risk or climate hazard indicators in order to see whether technology are available where they are needed. And so if you remember your mathematics class, the correlation coefficients means that which can go up to 1, means that the technologies are available in countries with high level of risks. So this is the good news. And of course, if the correlation is negative, it means that these technologies are available in places where they are less useful. They are useful, but in relative terms, less useful than in other countries. And so you can see that, in fact, for 3 hazard categories, flood, sea level, storms, you have a positive correlation coefficient, but this coefficient is very low, so and it is even not statistically different from 0, which is this solid black line here, vertical line. And in fact, you have the only thing which is statistically significant is this negative coefficient here for temperature increases, so PKT, which says that we have more technologies in places to mitigate heat waves in places where heat waves are less frequent. So basically, here the whole picture is a mismatch between technology access and. Okay, so let me just conclude with this presentation. Clearly, this project is a study which consists in measurements, and so it's not a study which look at solutions to promote the transfer or innovation in climate change adaptation technologies. It's just the first step, this necessary first step to first understand where we are now. Nevertheless, what kind of policy lessons we can draw from this? I think that the first thing is that this mismatch suggests that, in fact, today the economic forces that drives the transfer of patents. I remind you that all these patents they protect private innovation, in fact. So the economic forces do not seem to transform the needs into a market demand for these technologies, and especially in low-income and middle-income countries. And so it means that we need policies to correct market failures. So we need policies, which is not obvious for an economist, because in contrast with climate change mitigation, for climate change mitigation, there's the clear idea that we have an externality problem, so this environmental externality, which requires public intervention. With adaptations, it's more like a private good, which may justify less public interventions. But however, we see in this study that we clearly need policies to tackle. It's difficult, based on what we have done, to say more about these policies, because we need first to better understand what are the market failures that we need to correct with these policies. They are likely to be very different from one sector to another. Clearly, one market failure is the local availability of the technological capabilities, which are necessary to master and implement these technologies. But what else? What other failures? And the last lesson I see, it is the idea that given this concentration of this high concentration of the innovation in a few countries, clearly the international technology transfer is a crucial issue. Okay, so I think that's it. Thank you for your attention.
Thank you, Matthew. So we will now move to our discussants.
Okay, good morning, and thank you very much for having me. I find this the most interesting, rigorous, and exciting paper in an area that is largely under research. I must say I truly enjoyed it, partly because it complements the research prepared by same group of people. I think Damien Dussault and Simon Toubor, for a book that we just published on technology transfer and innovation for low carbon development, which looked exclusively at mitigation technology. So it is almost inevitable for me to compare the issues and results obtained in this paper on adaptation technology with those on mitigation technology. So first, let me start with the innovation. One of the results of this paper is that the number of inventions on adaptation technologies increased steadily between 1995 and 2015, but the share of adaptation inventions in the total number of inventions across all technologies has remained pretty much constant. And while, of course, mitigation technologies nearly doubled. And then much of the paper tries to explain this issue and this paradox. One of the issues, I think, is that the data stops in 2015, and I'm convinced that a lot more of adaptation in terms of technologies happened after that. And not for mitigation. What we know is that for all technology, and I think that there has been a decrease in the growth rate after 2012, and this is not a measurement error. This is a fact confirmed in many publications, OECD and others. So what happened? For mitigation technologies, we know that they are influenced by the price of oil. And the price of oil, of course, was very low at the end of 2008 to 2009. Then it went up, but by 2014, 15, it plunged again to a very low minimum. So that was one of the reasons why innovation kind of was low. And this teaches us a lot about what might happen now that the price of oil is so low. Second, of course, after the recessions that followed the economic crisis, made both public and private sector to invest a lot less in climate activities as other priorities became more urgent. And third, the mitigation technologies are also held back by a wide set of network externalities. So it is not just about having one more investment, but you need a number of interconnected low carbon investment, like, I don't know, I'm thinking about charging station for electrical vehicles. So as overall investment went down, this of course influenced renewable and other mitigation technologies. So I think some of these factors may have impacted on adaptation technologies, particularly of oil. I don't see how it could be connected, but it may be important to have a look at this. A second result I want to comment is the concentration of innovation in a limited number of countries. China, Germany, Japan, and Republic of Korea, and of course United States together account for nearly 2/3 of all high-value inventions filed globally between 2010 and 2015. And this is not at all a surprising result. So we get the same results for mitigation technology. It's got the same. I mean, the same countries. The big thing we see is China coming up very fast. I think it's now number 6 or 7 in terms of the world. I mean, capability to innovate, and the rise of these capabilities has been kind of incredible, because we see other emerging countries like South Africa or Mexico, Brazil, India. They are very, very far from where China is. But what I think is that basically the demand for climate mitigation and adaptation, both of them, rises with the level of income. So at very low income level, you find, if you want, a deficit of adaptation, because again, there are other concerns. So it's quite normal that low-income countries, poorer countries, do not innovate in any of the climate technologies. And in addition, I think the productivity of adaptation interventions is higher in developed countries because of factors like better infrastructures and stronger institutions. And that's another reason why you find more in these countries. I also believe that advanced countries might feel more inclined to spend more on mitigation, because emissions, no matter where they happen to be, they have a global impact, so they affect us. But adaptation is more local, so maybe something happened, in an island somewhere, and let it be. But if it is emission, that's important for us. And this is very much mirrored in the trends on climate finance, where we see that mitigation receives almost twice as much finance from both the private sector and the public sector than adaptation. So all these are good reasons for having more innovation in mitigation, I would think. But there is also a possibility that we lack good information on private investment in adaptation because this information is not officially reported, not easily quantifiable. Adaptation finance is also very difficult to track because it's not only at the the national level, but it goes down to provincial, to local level. So there could be a lot more than we think. And then finally, I want to comment on technology transfer. It appears that only 17% of the adaptation inventions cross at least one border, which is about half that of mitigation technology. But the kind of, if you want, strange results is that those inventions that actually make it and they cross at least one border are patented in around 5 patent offices, which suggests that, of course, they can be applied in many countries, and they're not so specific for a particular country, which is, something that I've always suspected. I mean, although needs are local, but some application can be very general. And I'm from Italy, and we have Roman bridges that have been standing for 2,000 years, through wars and all sorts of development, So perhaps there are certain designs, certain characteristics of the material that you use that are important but can be applied to to many countries. So the paper, of course, does not provide a good explanation for this low diffusion rate, although it points to some kind of intuitive factors like high barrier to technology transfer, tariffs, IP enforcement, etc., and lower applicability in the sense that some technologies are not tailored to specific contexts. And these are all good reasons, intuitively all very good, but you probably need to do more on the specific determinants of adaptation technologies. In our work, we found that the most important deterrent, if you want, to the transfer of the technology are capabilities. Because transferring technology is not just about the physical, the hardware that we transfer, but it is about transferring the know-how, and that needs a capability to understand, operate, maintain the technology, and also to modify. I mean, in most countries, whether it is mitigation or adaptation, the technology has to be modified, at least marginally. And so the poorest countries, those that are most affected by climate change, they do not have the capability necessary to deploy, operate, adapt, and innovate on this technology. And so what we find is that probably the most important question is not what everybody believes is the important one, which is, do you have the finance to buy this technology? But it could be, do you have the capabilities to, operate, adopt, understand the technology that you're in? So thank you very much. With this, I stop here.
Thank you, Miria. We wanted to remind people that you can ask questions connecting to slido.com and using the hashtag adapt2020, or if you're watching right now, you can scan the QR code with your phone. And this is how we can ask questions and vote those that are your favorite that you want to make sure our speakers reply to. With that, I want to move on to Christina.
Thank you so much, Isabel. And thank you for inviting me. My name is Christina Chan. I am the Director of the Climate Resilience Practice at World Resources Institute. And I wanted to thank Matthew for doing this study and for the World Bank for highlighting this through a webinar. As Miria said, I think this is a much under-highlighted, understudied area with respect to adaptation. The issue of innovation and technology, particularly technology transfer, has been raised by vulnerable countries in the global policy negotiations in the global policy context for quite some time. IPR issues come up, so I think the highlighting this is quite important, and we need to do more of it. I hope everyone, if they haven't already read Matthew's report and study, they do so. I think that Matthew highlighted a lot of interesting findings, good, important findings in his presentation. There's more in the study itself. I wanted to make a few reflections from my perspective, including working on the Global Commission on Adaptation. The first is, it's a question to Matthew and the other authors, how, and you recognize this in your study of the difficulty and the blurriness between identifying adaptation technologies versus non-adaptation technologies, which also help promote economic development. I think in light of the fact that you see both development deficits as well as adaptation deficits in low-income countries, it would be interesting to see if you were to expand your definition to include the sort of so-called non-adaptation technologies, if your findings would be any different. My guess is probably not, in light of the trends you were seeing with adaptation technologies being similar, not necessarily just specific to adaptation. It raises two questions for me. The two questions would be, one, what would be needed to overcome these transfer barriers? And that's a question I think Miria also raised in her comments. The second would be, so there's the what needs to be overcome to promote more technology transfer on adaptation. And the second would be how to increase the technological innovation in low-income countries, so the homegrown innovation, which would probably be two different questions, two different sets of answers. That said, I think something that your study pointed out, which would be important for either question, would be on, I think you say that in your study that part of the one major challenge with diffusion and transfer is with respect to technology capabilities. I'd be keen to hear from you, Matthew, a little bit more on what you would see as some key factors for technology innovation capabilities versus other sets of capabilities. A second point, really important, is finance. With respect to innovation and patents in low-income countries, I assume that one of the biggest barriers to this could be finance. If you look at technology, the three stages from research and development to testing and piloting to scaling up, public finance is quite important for R&D and that testing and piloting phase. And if you're looking at low-income countries with lower capacities on finance, public finance, that could be a major barrier to innovation, local innovation and local patents. Also, with respect to finance, we're seeing a lot in terms of international assistance, challenge grants, right, being a tool that's being used more and more to try to spur innovation and adaptation. I think which is great to see, how much are we learning from these individual innovation pilots and scaling? I think that there's more that we need to be doing in terms of a theory of change to get from that sort of the piloting of innovation and technology to scaling, and that includes public-private partnerships. Another reflection had is, Matthew, you spoke about policies. I do wonder if you looked at all into patent laws themselves, both the sort of different ways in which patent laws in terms of conditional patenting, humanitarian pooling, and whether those sort of modalities can help with improving sort of the transfer of technology from middle and high to low income. The final reflection and point I would want to make is the fact that, and I know you framed this in your presentation, that in this study you're looking at technology innovation. But I think it's an important point to make that innovation is not just technology, and a lot of these issues around diffusion and innovation in low-income countries touch upon the fact that you've got to be looking at other issues, other types of innovation. In the UNFCCC process, you've got the Technology Executive Committee, I believe, putting out papers sort of defining that there's technology information, there's innovation in technology with respect to hardware, but we also need to be looking at software and orgware as well when it comes to technology. And this important point that has come up a lot in our work in the Global Commission on Adaptation around co-creation. That co-creation and engagement and ownership by local actors is absolutely key, both in terms of spurring context-specific innovation, as well as in terms of helping with uptake and scaling. So those are just a few reflections on my part. I just wanted to thank you again, Matthew, for putting out such an important study. Thank you.
Thank you all. So now we'll move to Q&A, and let me pull up here are questions. And Julie and David will help us moderate this Q&A session.
Thank you, Christina and Miria and Isabel. So some really interesting questions coming up here. I was wondering if we could address the one that Christina just asked, though, because I'm very interested in the answer to that about whether or not you looked at patent law and regulation, Matthew. Just very quickly, can you respond to that one?
Yes. I just want first to make a general point about the difference between mitigation and adaptation. I think that the main difference between the two is that mitigation is here to reduce emissions, and emissions today they are located in the global north and in fast-growing emerging economies such as China. So this is where these technologies are needed. And these are regions where you have already strong technological capabilities. And in my view, this explains why things are going better in this area. With adaptation, the needs they are in low-income countries and less advanced middle-income countries. And so I think this is the main ingredients when comparing mitigation and adaptation. So on policy issues, first of all, in my view, the priority today is technology transfer. But saying so doesn't mean that I ignore domestic innovation, because I strongly believe, and the literature, the economic literature has brought interesting findings on this. I strongly believe that domestic innovations and the imports of foreign technologies are complements. I think you need to learn to create your own technology. You need to import foreign technologies. China and Japan has done so in the 20th century with great success. So if the priority is on technology transfer, I think another lesson of Untitled Chapter is the importance of the foreign direct investments, FDI. So private finance, and not public finance, private finance. And I think that we should, so we should imagine public policies that promote foreign direct investments,
yep,
including public finance, by the way. So public-private partnerships in this way are very important.
sure.
I think we should again not.
Matthew, can I stop you there? We have just 3 more minutes, and I wanted to make sure we get to at least one of the other questions. Is that okay?
Okay. Okay.
So we are looking at the questions. One of the most popular ones was.
Okay.
Is that if we don't mitigate, we're going to need more adaptation. Do we think that this might explain the higher level investment in technology transfer for mitigation? That's the most popular question on this list.
Can I try to give?
Yeah, go ahead.
Yeah. Well, I'm biased, so I really think we need more mitigation technologies, because the ultimate answer to adaptation is mitigation. I mean, if you do not mitigate, your investment, your need for adaptation will continue to grow. And yes, so far, emissions have been mostly in the north, let's say advanced countries, but we need more technology transfer to low and middle income countries, because that's where emissions will be in the future. So that's really the place to go.
Okay. The next most popular question was, why do we think more technology transfer is not happening? I mean, from our own experience in GFDRR, we have an innovation labs team that does nothing but try to develop, new solutions that can be applicable and customized and used for developing country clients. We do that with grants and lessons learned and challenge funds, but it's still small. Any other responses around why that technology transfer is not happening? That's really the biggest question, I guess.
Yes. Now our experience, it is transferred mostly through the private sector. Private sector goes where there are good opportunities, and many developing countries do not, they're I don't know, they have high tariffs or FDI controls, or there are a number of policy constraints that inhibit at least the private sector to move strongly, with foreign investments.
Mm-hmm. Matthew, in the last minute that we have, any other last answers? Can you give us some hope? Because it looks like a very uphill battle. We're talking about a lot of the constraints. Anything that gives you hope in the research that you've done and you're thinking about this topic?
Hope. No, I think that's the major reasons why it is not going so well. It's simply because the needs are not in the same countries compared to mitigation, and so. So basically, with adaptation and in contrast with mitigations, the hope is to have better development policies in general. Generic development policies are the useful tool to address these issues for adaptation. So how I see it at the part.
Mm-hmm. Okay. Great. Should we do one more question, Isabel, or should we wrap it up?
We can answer one more.
Okay. What about this one about SMEs, entrepreneurs? I mean, if you were in an environment where more technology was transferring, you would actually have a jobs impact as well. Any ideas about how we help firms in developing countries who do have the capacity, who are trying to grow in terms of the solutions they offer in their own countries?
Good immigration policy. I mean, to let these people circulate in the world and we exchange ideas with people. I think that this is, in my view, the main tool.
Yeah. Okay, Christina, should we let you have the last word if you have any? Last words on.
Last word. Wow, that's.
Sorry, I'm putting you on the spot, but.
I wanted to go back to the mitigation question, the first one you asked, and I absolutely agree with what Miria said in terms of the importance of mitigating. That the mitigation is the best form of adaptation ultimately. But I also go back to the question I raised earlier, which is, so much of what we do in development and agriculture, also in disaster risk reduction, for example, helps fill both that development and adaptation deficit. And I do wonder if the picture would look different if we expanded our scope. I think it's easier to count mitigation, right? It looks different versus how we count adaptation. And this point that Miria raised about private sector with respect to technology transfers is also important in the sense that we can't count, we aren't seeing the private sector as much, but you also can't count it, which makes it harder to say. Not the greatest last words, but I just wanted to jump in on those 2 points.
Yeah. Okay, then just to close it up, Matthew and Simon, thank you so much for sharing this research. As we mentioned, sort of a first of its kind. It was great to have the discussion, Christina and Miria, and thank you everyone for listening in. This is certainly an uphill battle, but we're beginning to understand the problem a little bit better, and that's an important first step. Isabel, anything else from you in terms of closing?
Thank you.
Thank you.
Thank you.
Thank you all. So like we said at the beginning, this is part of the Sustainable Recovery series. We have more events coming up throughout June. You can scan the QR code for the calendar, or visit the World Bank or the Innovate for Climate website. As we said in the beginning, this was recorded, and so this will be available on the Innovate for Climate website shortly. Thank you again for joining us. Goodbye.